Here we go, part 2 of lesson 1-8, roots. Good luck today. Make sure you pause if you need to copy something. We're going to cruise through this. Make sure you take the time to ask questions, jump on to GoGuardian, or ask to meet with one of the teachers in Zoom so you can review anything that's confusing. Okay, here we go. Read through the objectives and copy them down into your notes. Okay, we're going to use square roots to find side lengths of squares. We're going to find cube roots, and then we're going to solve equations involving cube roots. Here's a quick review. All right, let's do the first one. Why don't you copy these down, pause, do them, and see how you do. All right, no, really, pause. Okay, now we're back. Let's go. Square root of negative 16. Well, can you think of anything that would multiply by itself to get you negative 16? I can't. If you remember correctly, we will write no real solution. All right, and that's because 4 times 4 gives you positive 16, and negative 4 times negative 4 gives you negative 6. No, it doesn't. If it did, then we wouldn't be writing no real solution. There we go. A negative times a negative also gives you a positive. So none of them equal are negative 16. All right, now we're solving an equation with x squared. So we can use the inverse operation, which is square rooting. We have to do it to both sides. Those cancel out because they're inverses, and we square root 169. And we have to remember that there are two answers to this type of equation. There we have 14 and negative 14. All right, why? Because 14 times 14 is 196, and also negative 14 times negative 14 gives us 196. Next two problems, we're going to square root 0.25. Well, we know the square root of 25 equals 5, so it could be some variation of 5, maybe 0.5, maybe 0.05. Well, we have to just kind of guess and check. Let's try it out. So let's try 0.5 first. 0.5 times 0.5, if we multiply that, we get 25, and we have two decimal places, so 1, 2. Yay, that's 0.25, so our answer is going to be 0.5. All right, and you'll notice that the answers to these types of problem, when we're finding square roots of decimals, the number of decimals in our answer is half of the number in our the number we're trying to find the square root of. So there's 2 inside the radical symbol, and then there's going to be 1 in our answer, half as many. Why? Well, because when we go check our work, we're going to add up those 2 and get the 2 decimals that we had. So if there's 1 in our answer, there's going to be double that, or 2 in our in the resulting number. Okay, square root of fractions. This is pretty simple. I put this negative symbol out front to remind you. If you see it out front, not inside the radical symbol, then our answer is going to be negative. And we simply take the square root of the top, and we take the square root of the bottom, and we get our answer of negative 5/7. All right, hopefully you did pretty well reviewing what we did way back on Thursday and Friday. Okay, next we're going to start our lesson, area and side lengths of squares. We want to use that relationship to find a missing side length, all right? So if we're given the area, can we find the side lengths? If we're given the side lengths, can we find the area? All right, let's start with number 1 here. Find the side length of a square with an area of 64. Well, I've already written down the directions here, or the steps. So first step, number 1, is to write the formula for the area of a square. I should say square. There we go. All right, and area of a square is area equals side squared. Now, square is just a special type of rectangle, so you could do length times width. But then you realize, wait, the length and width are the same. So let's just use one variable to represent both of those, and that's s for side length. And we can do that little square to say that we're just going to times it by itself. All right, now we're going to substitute the area for A. All right, we're going to substitute in the area for A. So what's the area that they gave us? They gave us the area of 64, so we're going to take out the big capital A and replace it with 64, and just carry down here the S squared. Now, you could think, what number times itself is going to give us 64? Some of you might say 8 right off the bat. Well, that's great if you did. We're going to show a little more work to show the inverse operation, and so we can isolate that variable. Now, we know that if we do set up this type of equation, it often gives us two answers, right? 8 and -8, right? But can you have a negative length of a square? No, you can't. So we're just going to say 8 centimeters as the length of that square. That would give us an area of 64. All right, so we just square root the area to get the length, the side length of a square. Here we have area equals 100 centimeters. What is that side length? And we're assuming that this is a square, just like the one previous problem we did. So what do? We write down the formula. Oops. We write down the formula, which is area equals side length squared. And we replace the A with 100. And now we do the inverse operation to cancel out the square, leaving side isolated. Square root of 100 is going to be 10 and -10, but we don't need the -10 since we're talking about a square. So since that was centimeters squared, our length is going to be just regular centimeters. 10 centimeters, side length of 10 centimeters, right? If we envision that square, if it's 10 by 10, then it would have an area of 100. Length times width, 10 times 10, 100. All right, try this one. Pause it. Try it yourself. And then unpause and see how you did. All right, we're back. Write this formula. Replace the A with the 144. And we're going to try to find that S. Okay, we're going to isolate this S, get rid of that little squared by doing the inverse operation. We get S by itself. Square root of 144 gets us 12 and -12. But since we're doing it for a square, we don't need the negative answer. It was inches squared here, so this answer for side length is just going to be regular inches, 12 inches. All right, moving on. If that went too fast, rewind it. Go back. All right, and watch it again. Finding cube roots. All right, cube roots, like square roots, numbers that multiply by themselves to get that number. But this time, we need 3 numbers, 3 equal factors that will get you that number. All right, since 4 times 4 times 4 is 64, 4 is the cube root of 64. All right, that equal factor. All right, a perfect cube, numbers that are cubes of whole numbers. So let's use that same example. 4 times 4 times 4 equals 64. 64 is a perfect cube because you get it by multiplying a whole number like 4 times itself 3 times. So this guy, 64, is a perfect cube. All right, there's your cube root symbol. And then let's do some work here to find cube roots. All right, you see the 125 is in the cube root symbol. It's just a radical symbol with a little tiny 3 in front. We can think, well, 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. All right, we can do all the math. We can just kind of like guess and check until we get up to a number that we want. And this time we want 125. And if we keep rolling and doing that mental math, the 3 numbers times a number times itself 3 times, we finally come to the idea that 5 is the cube root of 125. Why? Because you can use it as a factor 3 times, and it equals 125. Okay? So now you're looking at number 2. And you might be thinking, you're not going to trick me this time, Mr. Woodworth. I see that negative in there. I see that negative in that radical symbol. I know that you're just going to get no real solution or no real answer or something like that. But think again, because if you do a negative times another negative, remember, because cube root says you have to use the factor 3 times, can you get a negative? Can you get a negative when you multiply 3 negatives? And the answer, hopefully, flying out of your mouth right now is yes, you can. So now with cube roots, we can get an answer when we're taking the cube root of a negative number. And what would the cube root of negative 27 be? I hope you said negative 3. Why? Because negative 3 times negative 3 times negative 3. Let's see, that gives me positive 9. And if I bring down this other negative 3 and do a positive times a negative, I get a negative 27. Woohoo! Why? Because negative 3 times negative 3 times negative 3 equals 27. All right. We're on to our last section. Woohoo! We are trying to solve equations with cubes. Well, guess what? It's inverse operations again, right? If we want to figure out, this is just saying what number to the third power is going to give us 8, you might already know that number, right? You might know, well, 2 times 2 times 2 equals 8. So the answer is 2. Well, we can also use the inverse operation here. And these cancel, leaving s by itself. Then we just have to cube root the 8, and we get 2. So 2 is going to be our answer. Well, I gave you that equation because I want you to apply it when we have volume problems. All right, volume problems. So our first step in these volume problems, where they give us the volume, okay, they give you the volume, but you have to find the side length. First step is formula. Write it. Okay, formula. What is the formula for volume of a cube? Volume equals, well, for a rectangular prism, it'd be length times width times height. But since all of those values are the same, we can just use one variable. And how do I say multiply by itself 3 times? Put a 3 there. So that's our formula for the volume of a cube. Okay, volume of a cube formula. All right, 2, plug in the volume that's given. All right, and in this case, it's 27. Now, you might have come up with an easier way to do this. You might just think, well, it's going to be side times side times side, and since it's 27, I just have to figure out the cube root of 27. Well, that's great if that works for you. I am doing a little bit longer, and I'm finding, and I'm showing my work using algebra. So I have my formula. I replace the v with 27, and now I'm going to isolate the variable. Oops, I need the little 3 there. And now I do it to the other side as well. And I get s all by itself, and I have the cube root of 27, which is going to be 3. And I notice I go up here and I see my inches cubed. So when I'm talking about length, I just use regular units. So it's not going to be inches cubed. It's not going to be inches squared. It's just a length, so it's going to be 3 inches. Bingo. All right. Well, go back and rewatch it just for fun, or not. But if you need some help, make sure you check in. If any of that was confusing, please, please, please ask questions. All right. Good luck with your work today, and have an awesome afternoon.